I have this old smoke detector. I had to replace it because, well, it needed replacing. It says on the side here, don't know if you can see that, replaced by September 2022. Well, it's currently December 2023, so this did need replacing. It started chiming when there was no reason to. Well, this is an opportunity because this is a type of smoke detector I've not seen before. It's an optical one. So I thought, let's crack it open, see what's inside. Now, I know that this doesn't contain a radioactive source. It doesn't say it does anywhere. And if it did, it would have to have that trifoil or trefoil radioactivity symbol that we all know. It doesn't say that anywhere on here, so I don't think this is a smoke detector that contains the radioactive source. It's called an optical smoke detector. Now, I haven't looked into what that means yet, but I think that means that it uses light. Well, obviously, it means it uses light, so I've just been distracted because I'm looking inside here. It uses light, perhaps when smoke gets in, it blocks some light, maybe some sort of light sensor. Well, let's have a look. And I've just looked in there and I've seen this, where the smoke can get into this gap. There's something in there that's shiny. So perhaps when we crack it open, we'll be able to see what that is. I've not opened one of these before. I've done no research into any of this. Don't think this has got a battery backup. Let's have a look what it says. Mains power. No battery, it says. It says no battery on it, so it's probably fine. I actually had two of these in my house, so if I mess up the first one of these, I had to replace both of them. So this one, I crack it and smash it up and don't actually learn anything. I can always open the second one. Science involves repetition sometimes. Right, let's take that screw out. So there's my two screws. Don't need them. And, that bit opens up. There's all sorts of dust and stuff in there. Look at that, spider webs and all sorts. Button's not doing anything. That plastic bit of cover does. Take that off. Seems to be blocking this component there. Looks like a capacitor. I'm just going to see if I can see what it is with my bad eyes. No, my eyesight's not good enough. I can't easily see that. I'll have to get a magnifying glass or something out later. Right, is this stuck in place somehow? Give it a little bit of a wiggle, see if it comes out. No, seems to be screwed in. This bit seems to be coming off though. So let's take that bit off. Oh, hello. Hello, it's got batteries in it. Look at that. 1, 2, 3 batteries. 3-volt Panasonic VL2330s. I've heard of them before. It says there, no battery. No battery. There's 1, 2, 3 of them. Lied to us. Right. I think there's a screw underneath this sticker. So this sticker needs to come off. I'm going to get the sticker off. Well, if there is a screw under there, I can't see it. Stick that there. That away. What is that in there? Oh, they're just solder points or something. Right, what's catching? That's a button that pushes all the way down to there, so that should be able to just slide out, surely. And then, where's it catching? I'm sure this is absolutely riveting stuff to watch. Can you see any other screws on there? I mean, that sort of catches, hello. That catches there. There's these plastic catchers. Right. So if I can push around these plastic catchers, I'll be able to remove this circuit board. Is there another one? There's one in there. See if I can... caught there. There we go. Right. Big old empty plastic thing that can be chucked. Here's the guts. Now that all appears to be soldered on. That obviously is the part that makes the loud chiming sound. Piezoelectric buzzer of some sort. Yeah, there it is. That's the piezoelectric buzzer. I'll take the plastic case off that. There it is. Stuck in with good old-fashioned silicone. Scrape that off. So there's your piezoelectric buzzer. I might play with that later. We know that these things are loud, so that must be good fun. So I'll play with that later. Red, white, and around the outside rim is black. It's red to this part here, white to this bit in the middle, black on the edge. I'll look that up later. Right, so I can get this button off. Right, what is this? Why can't I not get this case off? Where does the smoke get into it? Wherever the smoke has to get into it to trigger something. But this all looks a bit sealed, doesn't it? Right, we've got these catches here. Let's push those catches. Right, so this just looks like a black plastic silicone in it. This just looks like a black plastic box of some sort. Doesn't look like there's anything exciting in here. A couple of catches at the side. There's a filter. Don't know what that filter's for. And so whatever the detector is, it must be inside that black box. It must be this thing here. That's the only thing it can be. Reckon I can take these cells out, or are they soldered in? No, they look like they're soldered in place, don't they? These cells. But that's the interesting bit. No, it's soldered in, so have I got my soldering iron with me? Oh, blast, I left it at home. Why is it connected to that metal plate there? How odd. But looking inside there, I don't know if you can see inside there, appears to be some sort of either a sensor or something. And there's another thing inside there. Could be an LED of some sort. Can this open up? That bit slides off the side. But it can't because of that plastic bit there. Oops, bent that transistor pin. I don't want to break anything, so I shouldn't have to force it. Right, there seems to be a catch there. And that side, okay. This side here does just look like an LED. Could be an infrared LED or something. Should we get a power supply and start randomly powering bits up? Now these bits can be used as probes for multimeters, but they could also be connected to our power supply. Let's stick it on 3 volts, keep it safe for now. And these can actually be connected to our power supply, so we can stick 3 volts across stuff. Now there's no safety resistors in this circuit. There's always a chance we blow stuff up, but let's find out. There's our piezoelectric buzzer. Not sure what's going to happen if presumably it'll need an oscillator, so just DC. Might be very exciting across the oscillator, no matter how big a potential difference. Might just be able to hear it tapping slightly. Hello, the LED appears to be flashing. How fascinating. Did you hear that? How fascinating. Let's whack up the voltage a little bit. That LED is still flashing, so it's probably this capacitor's discharging through it. It's flashing. Oh, that's a fun noise. Makes a tiny bit of noise. Okay. I wonder if I connect that to an AC, I'll be able to I was hoping I could get some sort of 50 hertz rumble from it, but never mind. Let's stick that power supply back on DC. Obviously charging up a capacitor somewhere, because it's making that LED, that red LED flash. Not sure if you can see that happening. Right, so that's that. Now, I wanted to see what this LED was, so which side do you reckon is the positive? No idea. This is optical, but that doesn't mean it's visible light. Let's just shove these probes. Set down to 5 volts. Let's shove these in there. Might be the other way around. Can't see anything interesting happening there. Right. What else can we fiddle with? Well, this is interesting here. If I look closely, let's use this probe as a pointer. It's turned off now. Can you see there's a, I think it's a resistor or something soldered, so it's across this chip there. Interesting. I'm still really fascinated by this part there. What's going on there? Anyway, let's carry on trying to brute force this plastic case off. I haven't got my solder removal tool with me here. I left it at home. Because I didn't think I was going to do this, but I've got marking to do, so I'm procrastinating. Okay. Are you beeping at me for? Needless to say, you shouldn't do this at home if you don't know what you're doing. It could be dangerous. Hello, look at that. So I'm not sure if you can see this. I think that might be the sensor there. And yeah, this bit in there was just some sort of LED. That bit, just some sort of LED. So let's connect it down here. Let's see whether I can get the thing to turn on. If it's infrared and it turns on, then we'd be able to tell it's infrared because the camera on my phone would pick it up. I don't know what potential difference it needs, and I'm just shoving it across here, but I don't know what else there is in the circuit. So I might have to actually snip this component out so I can find out what it is. Yeah, let's snip that component out. So here it is. There's a big horrible plastic bit here. Move that to one side. It says that that leg is supposed to be positive, and that leg is, no, I've lost which one's positive and negative now. It doesn't matter because one of the sides on the LED is flatter, so we know how to connect an LED. Let's just separate these two out. Right, let's go get some crocodile clips. And this bit over, unplug that. This bit over here is the mains adapter here. Connects into into the mains of my house, so that it's always powered. Right, let's go. No safety resistor. Let's turn the voltage right the way down. Let's go like this. It's supposed to obviously have a safety resistor with any sort of LED, otherwise it will quickly get too hot and destroy itself. Pretty sure I've connected that right. Let's connect it the other way. Well, if that's emitting infrared, it can't be detected by my camera. So I'm not sure what that's doing. I suppose I could have broken it by accident. It does say on it, I red. So I think that does use infrared. Now, if that uses infrared, then this must be some sort of, crack that open. That bit in there must be some sort of infrared sensor. This is the destructive testing. That I just don't understand at all, just a random piece of metal. Bunch of resistors, Shove that in there. Bunch of resistors. There it is. So, looking inside it, it appears to have some sort of yellowy coloured envelope, plastic envelope, and inside it is a black rectangle, presumably some sort of metal. Not sure what metal it is. It'd be quite interesting to measure current through it, potential difference across it. In fact, yeah, let's get my multimeter out. Let's do some measurements. I'm just going to take off the piezoelectric bit. I'm going to play with that later. Yeah, let's go get my multimeter. Let's put this connected as an ohm meter. Show you the screen. Let's move all this stuff out the way, all the guts of this thing. There you go. Let's just connect this like this. And the other side will connect to the other side of the ohm meter. Now, showing as a resistance, we've got 3.3 mega ohms. In the darkness, it's dropping. It's 1.2 mega ohms there. It's not quite as dark as it could be. Oh no, I've just shorted it out. Let's try that again. Okay, we're down to 180 kilo ohms, 175 kilo ohms, and in the light, let's get that in the light, 293 kilo ohms, so not mega ohms at all, 308 kilo ohms, and cover it up, get it in dark, 184, 300. Okay, so that seems to be just an LDR, light dependent resistor. It's not a design I've seen before. But there we go. The resistance of that seems to change depending on the the light intensity. Let's just try on the voltmeter setting, see what happens. Okay, so that's interesting. It says we've got a DC potential difference right now. It's only in the millivolts, 300 odd millivolts. When I cover it up, it drops right the way down. If I cover it up enough, oh, it's actually going negative. Fascinating. It's dropped right down to very low, and then light goes back up again. So there's actually a measurable potential difference. So that's working like almost like a photovoltaic cell. Let's pop this onto the current setting. See if there's any current flowing. In microamps, dropping down to 0. Then look, we've got 5 microamps, 6 microamps, dropping down to 0. So there is a current passing through it. And if I swap these around, will the current go negative? Which it should do, I suppose. Yeah, it does. It does. So there's a polarity to this. There's a direction. Current's flowing in a particular way through this. So I'm not sure how LDRs work. Well, let's go get an LDR. Let's go find out. Here's the LDR with which we are more familiar. This one's mounted on an electronics thing, but it doesn't matter. Let's see if LDRs behave the same way. I mean, they don't look the same, do they? Let's see if they behave the same way. Connected to a microammeter. No current, plenty of light. No current. Connected to a voltmeter. No potential difference across it. Connected to an ohm meter. Okay, 1 odd kilo ohm. Going up to millions, nearly millions of ohms, 0.9 mega ohms. There we are, 1 mega ohm. With light dropping right the way down to kilo ohms. So that's a light-dependent resistor. This is not a light-dependent resistor because there is clearly I don't know what it's doing now. Let's put it down to the voltage setting. There's clearly, turn these wires around, a potential difference across it that reduces in the dark. It's weird that it goes negative and then goes back to near enough 0. That's odd. That's interesting. That's interesting. So I think that uses the photoelectric effect. I think this is a photo cell using the photoelectric effect. All right, the last thing I'm going to do with this, we've investigated this. I think this is some sort of photoelectric cell. And I'll keep that and I'll play with that later. The last thing I want to do with this is measure the potential difference across this as I try and change its shape. So if I get this connected to perhaps the red one, to strip some of this wire, and I won't bother stripping the black one, I'll just connect this straight onto it. So you've got potential difference, which, can I get any sort of sensible, measurable change as I change its shape? I mean, it's jumping all over the place. I'll see if I can make a pressure sensor out of it, you see. All right, let's strip this. Because that's the way piezoelectric stuff works. is you put a potential difference across it and you change its shape. Great, fine. But that also means that if you change its shape, you get a potential difference measured across it. Right, what's that showing? 0.6-ish volts. Oh, it went up suddenly. Now it's going negative as it relaxes. So, goes up very high positive, went up to 30, or it goes down negative when it relaxes. I wonder if I can use it to push some charge through. So microamps, 3 microamps, negative. Yeah, look at that. Oh no, now it's not working. 1, 1. Let's push it. 2. Let's push it to get 2, and then I'll wait for it to settle, and then I'll pull it and see if I can get negative. So let's leave it for a second. 2, back down to 0, and then, no. Oh, that one did it. Interesting. Resistance. Too big. Well, it will be. Big crystal. Momentarily it goes up very high, doesn't it? It's be fun to look at with an analog meter. Should I get an analog meter? No, I've been playing around with this for about half an hour now, so I think I'll stop. I've got stuff to do. Well, anyway, there we go. That's inside an optical smoke alarm. Photocell, that uses the photoelectric effect. I'll look that up later. Infrared diode. Infrared, lower energy than visible light, but it was all kept in a nice black container. I'm guessing smoke gets in between here, blocking, get in between these two, blocking the light getting from the infrared to the to the photocell. That's going to cause a signal. Circuitry detects that and causes that to beep. What these batteries do, I don't know. I'm guessing they allow it to beep when it's disconnected from the mains or something. But whether it works when it disconnects from the mains or not, I don't know. There we are. Exciting stuff.